Okay, this is your lesson on inverse trig functions. I'm going to go backwards now. We're going to try to find our angle given the ratio or the value of a trig function. Evaluating inverse sine functions and evaluating other inverse trig functions. The main thing to know that we've been taking a trig function of an angle and it gives us a ratio. If we take the cosine of theta, we get a ratio of, or should I say sine? The sine is going to be opposite over the hypotenuse, 1 over 2. So this is my angle, and this is my ratio. Make sure you understand that taking the trig function of an angle gives you a ratio. Okay, this will be 0 over something, right? Always gives you a ratio. So when we take the inverse sine or the arc sine, we take the arc sine of a ratio to find our angle. Sort of like logarithms and exponential functions. This arc sine function undoes this ratio into an angle. That is the main concept that you need to know for today. Okay, so let's talk about some of these. Angle ratio. Just a notation alert. I don't see this very much, but this is called an anti-sine x, arc sine x, inverse sine x. These are all the same. They all mean the same thing. This x is a ratio, and you're going to use this to get an angle. Now, make sure you understand that that is not the reciprocal. This tells you to take the reciprocal sign, and reciprocal sign is the cosecant. These are not cosecant. On your calculator, it's a big deal. Okay, so this is not an exponent. This is, this is an exponent. This gives you the inverse, while this is not an exponent. Okay, okay. So sine inverse is going to be cosecant. All right. So let's take a look at the sine curve. This is sine curve because it starts at the origin, it comes up, and it has a period of 2 pi. Its inverse, if we take the opposite of that, or not opposite, but the inverse function, that means we're going to make x equal the sine of y. We kind of flip this on its side. Now, when we use the vertical line test, this is a function. What happens over here, this is not a function because the vertical line test will run through many parts of my graph, infinite number, because this wave goes on forever up and forever down. So in order to make this work for a function, we're only going to take a piece of it, this little piece right here. That way, because this backs up on itself, it turns it into not a function, right? It would make it not a function if we couldn't pass the vertical line test. So we just take this little piece of it in order to work with that to make that a function. So now we can say that there is an inverse function for sine, but only for this little piece right here. So this is that little piece right here for the arc sine, the inverse sine. And for cosine, we're going to take this piece right here. There's a reason we do that, because that's just where we're going to keep them simple, and you'll see where it comes in a second. Okay, so the arc sine is from pi over 2, you see where it's pi over 2, to negative pi over 2. So it's pi over 2 to negative pi over 2, right? Going in the opposite direction, 90 degrees and negative 90 degrees. That's how this is set up, from negative 90 degrees to positive 90 degrees. That's my arc sine. So the domain is on the x-axis, will be from negative 1 to 1. It has to stay in here, because you remember when we turn this sine curve on in the proper way, it can only have a magnitude or amplitude of 1. It goes up 1 and goes down 1, right? That's where that comes from, because now we've turned it on its side. It only can go to the left 1 and to the right 1. Okay. The range will be from my negative pi over 2 to positive pi over 2. Okay. It can only go from negative pi over 2 to positive pi over 2. That's the whole range. Now, if we're talking about arc cosine, That's going to be this one over here. The arc cosine has a domain of -1 to 1 because that's the magnitude, right? The amplitude. Amplitude is going to be up 1 or down 1. Okay? And the range is from 0 to pi. It goes from 0 to pi, or 0 to 180. Okay? Cosine goes from -90 to +90, and the arc cosine goes from 0 to 180. All right, but always check to make sure your domain is between -1 and 1. This is the biggest error that people make when they're trying to use the arc cosine and arc sine. They don't check to make sure that it's in your domain. You're going to try to take the arc sine of like 5, and you're not going to be able to do that because the graph doesn't go that far. Quickly, just talk about tangent. Tangents are these blue lines, and arctangent is just the reflection on the diagonal here, so this would be the arctangent. And the domain for arctangent is going to be from -infinity, it goes all the way to the left, and positive infinity all the way to the right. The range, though, is going to be from pi over 2 to positive pi over 2, negative pi over 2 to positive pi over 2. And the cotangent is just slightly above that and has a domain of -infinity to positive infinity, and the range goes from 0 to pi. All right, so there are my diagrams for that. Cotangent is in quadrants 1 and 2. Tangent is in quadrants 1 and 4. So, finding the exact value of -1/2. Well, -1/2, you know that arc sine is in quadrants 1 and 4. -1/2 sine is this one right here, is cosine sine. So that will be equal to 11 pi over 6, or -1 pi over 6. Remember, these values are going to be in here, right? These values are going to be here, so it's going to be either up to a half pi or down to -½ pi. So 11 pi over 6 can't go that way. We can't go to 11 pi over 6. There's no circle here. It ends right here. It can't go that far up to 11 pi over 6 would be up here somewhere. So we're going to have to go backwards, go down, and that will be -1 pi over 6. Arc sine of rad 3 over 2, well, rad 3 over 2 would be right there. So that would be just pi over 3. And then last one here, arc sine of 2. There's no 2 on here, right? Always check. It has to be between -1 and 1. It's undefined. You can't do that one. All right. Arc cosine. Well, our cosine is this piece right here. Where is that? Cosine is the x value, so radical 2 over 2, that would be pi over 4. What about of -1? Well, that should be just pi. And then arctangent, this would be arctangent of 0. 0 would be 0, right? 0 over 1. This is your tangent, 0 over 1 sine over cosine. That will be 0. And the arctangent of -1, where's arctangent of -1? Right here. It's negative rad 2 over 2 divided by rad 2 over 2. So it would be 7 pi over 4. Or -1 pi over 4. Or -45 degrees instead of 315 degrees. All right. Doing these on your calculator, make sure you know how to do these. You should grab your calculator and put this in, and you should be able to get this. This is the one that looks like this on your calculator. Make sure this is in radians. Try this one. Pause the video if you need to. But you should get that. And then arc cosine is undefined, right? Always check. Arc cosine and sine has to be between -1 and 1. That's not going to work. You're going to get an error on your calculator. All right, this is almost done here. We have a 10-foot pole is secured with a cable, 15 feet from the base of the pole, find the angle of the cable right here. So the angle, we would take tangent because we have opposite over adjacent, right? So we find that to cancel out the tangent, we're going to use the arctangent of both sides. That'll cancel the tangent. My theta is going to be equal to arctangent of 10 over 15. Put that in your calculator, and you should get 33.7 degrees. Last example here. 10-foot pole is secured with a 15-foot cable. So now the cable is 15 foot long. Find the angle of elevation at a point where the cable is attached to the ground. So this is opposite over hypotenuse. That looks like a sine. And that would be 10 over 15. Take the arc sine to cancel out the sine. So then you're going to get 41.8. That's it.